Hi girls, today we are going to correct section review page 501. I will correct with you 3, 4, 5. Let's start with number 3. Predict the image position. Since they said predict the image position, so what do we want? We want Q. Q is the image distance for an object placed 3 centimeters outside the focal point. So the object is placed 3 centimeters outside the focal point of a converging lens. We have a converging lens and the object is placed outside the focal point of 3 centimeters. Okay, so pay attention here. P, here is the object. P, we know that it is the object distance and it's the distance from the lens to the object and not from the focal point to the object. Okay, so here we have to continue till the end. Of a converging lens with 4 centimeters focal length. The focal length of this converging lens is 4 centimeter. Okay, therefore P, which is the object distance, it's 4 plus 3. Okay, so P, the object distance, is 4 plus 3. It's 7 centimeters. So pay attention. Okay, complete the sentence before you directly put the givens. So 3 centimeters outside the focal point, not from the lens. This distance must be measured from the lens itself, not from the focal point. Okay, so from the lens to this, it's 4 and 3, so it gives us 7. Okay, and the focal length is 4 centimeter. I will keep it positive since our lens is converging. Okay, these are my givens. What equation I have? I have the thin lines equation, 1 over P plus 1 over Q equals 1 over F. Let's substitute together. What is P? It's 7. 1 over 7 plus 1 over Q. Q is unknown, is equal to 1 over 4. Okay, what do I want? I want Q. 1 over Q first. I will get it. Equals 1 over 4 negative 1 over 7. You will get this number on calculator. Okay, you get it in fraction, for example, or decimal, as you like. If you get it in decimal, okay, you will get like 0.25 minus 0.142, something like this. You will get a number, and then, so after getting 1 over Q, in order to get the Q, you will make the inverse of the answer you got, okay, in order to find Q. So Q will be directly 9.3 centimeters. 9.3 centimeters. So you can see that the sign of Q is positive. And what does this indicate? It indicates that the image produced is real. Okay, is real. It means it's produced where? Here or here? Since it's real, it's produced here, because here is the real path of light. The light comes from object and pass through the lens to the other side. Okay, so Q, the image produced is here, is real and inverted. We can see this from the sign of Q. And for sure we can see this because the object, where is it? It's outside F. So whenever the object is placed outside the focal point, so for sure the image created will be real. Only when the object is inside the focal length, in this case only the image created will be virtual. Okay, this is everything for number 3. Number 4, they want the magnification for this object from item 3. So magnification, it has two equations, negative Q over P and H prime over H. For sure, since we don't have any givens about this, I'm not going to use it. I'm going to use this. I got Q equals 9.3, so negative 9.3, and P, I have it, it's 7. So the answer that you are going to get is negative 1.3. Okay, so sure, the magnification negative, this proves that your image is inverted, and that's correct because all real images are inverted. And see, also here the image is larger than object, since the magnification is more than 1. Now focus with me, all of you girls, on number 5, because we are going to draw. In number 5, using ray diagram, find the position and the height of an image. Position of an image, it means we are going to get Q. Okay, position of image, it is the image distance, so Q is unknown. Height of the image, it means we are going to get H prime is the height of the image. Okay, produced by a viewfinder camera. So viewfinder camera is a diverging lens. I told you that it's the camera, the small camera in the phone that makes the image sharper. So whatever, this camera is diverging. Okay, it will be given in an exercise. Like if you have something new, I will tell you if it's converging or diverging. Now, with a focal length of 5 centimeters. So since this camera is diverging, so our focal length is what? Negative. Pay attention, all diverging lenses are they have negative focal lengths, and that's why sometimes they are called negative lenses. Okay, negative 5. And if the object is 1 centimeter tall, so this is the height of the object, 1 centimeter. H stands for height of object. H prime stands for height of image. Same thing as in the previous chapter. Now, and 10 centimeter in front of the lens. So the object is placed 10 centimeter in front of the lens. So this is the object distance, object position. And at the end, they told you that the camera viewfinder is a diverging lens. Let's draw together. First, I will draw the principal axis. And I will place my diverging lens. My diverging lens, I can just draw a line with upside arrows. This is my diverging lens. Then, I need to place a focal point and I need to place object. Let's do a scale. Let's see. The object 10 centimeter. The focal length 5 centimeter. Okay, 10 centimeter. See, it's a big distance. I can't draw it here on a paper, so I need a smaller distance. Okay, so let's say that P, which is 10 centimeter, in reality, it's on my paper 5 centimeters. Okay, let me measure 5 centimeters. This is 5 and this is P. Okay, so here is my object. My object is 1 centimeter. Just draw it 1 centimeter. Okay. What else? The focal length is 5 centimeter, negative 5. So on my paper, it is 2.5 centimeter. Since 10 centimeters are represented by 5, okay, so 5 represented by what? By 2.5. 2.5, okay, this is the focal point. Okay, from the other side also I have to place the focal point because it helps me to draw the rays. Okay, let's revise the rays together. I have 3 standard rays. The first one is the one that is parallel to the principal axis. See, this is the principal axis. I take it parallel to it. Okay, parallel to the principal axis. Ray number 1. How will it refract now? The ray will not bounce back. We are not talking about mirrors. This is a lens. The ray will pass to the other side. For sure, it's a transparent object. It can pass through it to the other side. So, it will refract. It will pass to the other side. But how? It will pass to the other side as if it's coming from where? From the focal point, because it's diverging lens. We learned this from the first case for diverging lens. We said when we have a very far object, all rays that are coming parallel, they diverge away from each other as like they were coming from focus here. okay, as if like they are originated from here. Okay, this is the first one. The second one, it is the opposite to the first. It is the one that is directed. See, I make it straight. I connect the tip of the object with the focal point. It is the one that is directed toward this focal point. And when it reaches the lens, how will it refract? It will refract parallel to the principal axis. If you feel that this ray is hard for you, okay, no problem. You can draw the easy one. What is it? The easy one is the one that is going toward the center. The third ray is the one that passes through the center. And how does it refract? Here, this ray, it doesn't refract at all. It continues without any refraction. See, girls, these rays, are they going to meet anywhere? Just to draw this one with another color, number 2. Okay. So for sure they are not going to meet. They are not going to meet, even if we extend them. So what we have to do is to trace them back. See, this one, it's already traced back, and this one, and this one. Okay, so this one, it's traced back. I trace back this, and I trace back this, so they will meet all of them here. See the image, how small it is. It is very small. This is so, see, girls, the image produced is virtual, upright, and diminished, reduced. And this is the image produced by diverging lens. It always has the same characteristics. Okay, here I drew for you only 2 rays to don't like complicate the drawing. Okay, you can do this when you have diverging lens. Okay, so if you feel that the second ray is hard for you, you can draw only the first one and the third one. Okay, the one that passes through the center and continues without any refraction. Okay, so girls, they asked us about Q and height of the image. They said using ray diagrams, but since using ray diagrams we are not going to get very accurate results, so I will use first the calculation in order to get Q and H prime. Q, how do I get it? By just using the thin lens equation, 1 over P plus 1 over Q equals 1 over F. I substitute and I get Q. If I want to make sure from the answer, okay, I can measure the image distance. Image distance is the image produced from the what's called the lens to the image. Okay, it's like 1.6. I got it from drawing. So from the drawing I got Q 1.6 centimeter, but this is on my paper, right? Okay, to get it, to have or to get the correct number in reality, we have to multiply by the scale. Here all the distances are reduced to half. Look, 10 is reduced to 5 on my paper. 5 is reduced to 2.5 on my paper. So this 1.6 centimeter on my paper, it's in reality it is 1.6 times 2. Okay, so it is like 3 point something 2, okay, centimeters. So close to my number, so that's correct. Okay, so I can check my always my final results from the drawing itself. Now, how to find H prime? H prime, we have it in the equation of magnification. Magnification is H prime over H. Okay, so what to do? How can I find magnification? I don't have it in my givens. So I will use the other equation first, magnification equals negative Q over P. I will get magnification, then I will substitute it here and get H prime from it. Okay, magnification negative Q over P, negative 3.3 over P, which is 10. I will get it. Okay, don't have the calculator now, so you get the, it's easy. It's 0.33, okay? 3.3 divided by 10. So this magnification, I will replace it here. See? M is H prime over H, right? So magnification, I got it to 0.33. H prime is unknown, and H is the height of the image, which is 1 centimeter. It's given. They said, sorry, the object is 1 centimeter tall. So this is the height of the object. So still only to what? H prime is this multiplies by this. So 0.33 times 1. So the height of the image, imagine it's 0.33 centimeters. It's reduced from 1. In reality, the object has 1 centimeter height to 0.33. So the image is reduced, diminished. Okay, this is everything about number 5. Now number 6. Number 6, compare the length of refracting telescope. So length, I want to compare the length of refracting telescope, okay, with the sum of focal length of its two lenses. It means with the sum of the focal length of the objective lens plus the focal length of eyepiece lens. We said that the refracting telescope, it has two lenses, okay? It has two lenses, and both of them are converging. Why? Because converging lens is the only lens that can give us a larger image. Diverging, it reduces the image, as you saw, girls, in number 5. So telescope the telescope, we use it to enlarge the object. So for sure we will use converging lenses. This is the objective, let's say here, and this is what the eyepiece, the one that we look through. Okay, so here the objective and here the eyepiece. So we are looking from here, and we are looking at a very far star, for example. The rays coming parallel and they enter, and we said, girls, when I explained this part yesterday, that the rays coming parallel from the star, for example, they will, when they pass through converging lens, they will bend and meet at the focal point of what? Of the objective lens. Okay, at the focal point of the objective lens. And we said, so this is the image, right? It's the point size. So the focal length of the eyepiece, we said it's where? It's behind this one. This is the focal length of the eyepiece. Why? It's made like this. Why? Because this one, it will be the object for the eyepiece. We hide this. This one, it will be the object now for the eyepiece. And when the object is inside the focal point, the image produced will be virtual and enlarged. Okay, virtual and enlarged. So that's why it's made in a way that its focal point is behind the focal point of the objective lens. Okay, so girls, this is the length of the telescope, all of it. Length of telescope. This is the length of telescope. And this is, let's say, this is the focal length of the objective, and this is the focal length of the eyepiece. Let's compare them. This length of telescope, is it equal, less, or more than the sum of this plus this? What you can notice here, it's smaller. Because, why? Because the focal point of the eyepiece is behind the focal point of the objective lens. So when I add this and this, they will be a little bigger, larger than the length of the telescope. So it's smaller. Okay, so this is everything about section review.